let's talk about vector search, and let's get more into the technical details of this new capability in 5.5. More specifically, maybe if one of you could walk me through the pipeline API that we have in our vector search.
Yeah, let's
Or anything.
let's just I can show you. Let's do that. So I'm going to share my
Great.
screen again.
I'm a visual learner.
Yeah, that's good. Okay. So that was the search half. Now we're going to talk about the load half.
All right.
All right. So this is our Hazelcast dashboard, and actually most of our capabilities you can kind of see from just looking down the left-hand side here, and we basically we store vectors and we also load vectors. So here's our dashboard on on top of the vector database, the vector store. And it just gives you information that an operator would want about how often it's getting hit and how much data it's collecting, or how much data it's how much memory it's consuming and things like that. But what I really wanted to show you is the pipeline, because that's what you asked about. So that is down here in this stream processing section. And pipelines look like this. They're a sequence of steps, and they're run distributed across the whole cluster. And I tell you what, let me actually just dump a few more images into the hopper, so to speak, so that so the pipeline will have something to process. So I'll grab another batch of images. Let's go with this one, this batch right here.
Wow, that's a lot of images.
Now like a couple, I think it's like a couple hundred. Grab those, and we will dump them in the hopper, which is here. And now we should see something happening. This thing only updates every few seconds, but basically, so this compute embedding stage, you can tell, I only ran one node. If there were more than one node running, it would have, more than two, kind of instances running at the same time. We deploy your pipeline to the whole cluster. But anyway, what we can see is kind of events in and events out. In this case, the events are images. So basically, let's look at the overall graph of this thing. So we wait for changes. We do some kind of minor formatting of the input. Then we compute the embedding. That's taking the image bytes and turning them into a vector. And then there's some munging of the output that has to happen. And then finally, we sync it into this vector collection. So I think we had 209 images before. Looks like we have, so we've processed 430. So half of these are log. So they're, twice as much. We've already processed all those images. So anyway, that's a pipeline. And just to quickly show you the code and the integration, I'll do that as well. So we won't go over it in excruciating detail, but basically you can see that there's basically a couple lines of code for each of those steps, each of those little boxes. And a lot of this is just our standard pipeline API, but at the very end of it, this is one of the integrations that we made for the vector collections. When we release vector collections, we integrated into the pipeline. So now there's this new sync. A sync is where the events generally or eventually end up. So they could end up in a map, or they could end up on a message queue or whatever. In this case, the events end up in a vector collection. And so adding your data to the vector collection is as simple as this. So you can see this is a pretty short pipeline. It's 100 lines of code, and most of it's white space. So it's pretty easy. We made it pretty easy to write a very scalable industrial grade process for ingesting your images.
Or whatever your data collection is.
Or right, your unstructured data. Exactly.
Yeah, I mean, this tutorial is obviously with images, but just to clarify is that, it doesn't have to be images.
Right.
It can be any unstructured data. That's the whole idea behind this. And so, in that ingestion step, that's where you have the pointer to whichever embedding model you're using. And then so compute embedding, that's that step. So that step can point to whichever model you want to use. I mean, I think we used clip for this, but I've seen a couple other demos that use
Yep.
different models.
Yep. And I'll just add that we actually, even though it's a Java product, this actually leverages Python. So this box here is a call out to a piece of Python that you write. And in this case, exactly what you said, Andy, it uses clip, which is a sentence transformer from Hugging Face, and it computes the embedding and sends it back basically into the pipeline to be parsed and sunk into the vector collection.
And that vector collection itself, just that's the data structure that Hazelcast created to store this information. Hazelcast is really good at key value stores. A vector collection is a specific type of key value store. The key is just, that's your reference for the values. In this case, the value is what's called the vector document. That vector document itself there's going to be one document for each entry that in the case of our image search, there's going to be one vector document for each image. And inside that vector document, it itself is a key value store where the key is the reference to the object. In this case, it's the URL for the image, and then all of the vectors that were generated in that embedding process. So that all gets built automatically as part of that embedding process. The one thing that we didn't show or didn't mention was the indexing that makes that search so much more efficient. Each one of those vectors that gets generated, you can create an index for. So if you wanted to have an index on, you have to specify which of those vectors those vector fields, I guess, you're going to create an index for. And I'll go back to my analogy. Maybe you have an index, that most of your searchers are going to look for a color element. So you create an index for color just to speed that process up. That then, so now we'll have an index for all of just that particular vector. So we're not having to search this entire massive vector collection. We're just going to search the index that references that particular vector. So when you enter your search strings, if it matches an index vector, we'll search the index rather than the entire data store. And that's just, it's next level indexing, but again, if you've been doing databases, you've been doing indexing for a long time. Same idea. We're just now be able to create an index an index that you create, or you will configure. It's a configuration element. You configure which indices you want to create. You can have one, you can have as many as you want.
There you go. There you go. So this is the Hazelcast configuration file, and you basically have a section where you list your vector collections. So this is a collection named images, and then each collection can have multiple indices. And when you create the index, you have to tell it the distance metric and the dimension of the vector. So, and those two things are basically properties of the embedding that you choose to use.
Before we close off, maybe what are each of you may be excited about with vector search, and where can people learn more?
I'm excited because it does open up this whole realm of data that Hazelcast really couldn't handle before, right? We, again, really, really good with structured data, but so much data is being generated out there now, and it's coming in so quickly, and we want to be more sophisticated than Control F, find runner, right? We want to be able to do these intelligent searches because that's what people, our customers are expecting because their customers are expecting that. So we now have the capability to be able to provide that functionality. So it's massive, and it's another one of those, the possibilities are endless, but they really are, because now we just have this huge capacity to handle data that previously it wasn't in we could do it, but that's not, that wasn't wasn't where we played. Now we can play in this whole space. And it's also, it's our first step, right? There's when the brains that are talking about, what is the next thing for Hazelcast, and really looking into how we can help our customers implement AI. This is step one. This is not the last step. It is the first. And so there's just a lot of, it's exciting to think of the possibilities of what's coming. I mean, this is new stuff. right? It's just fun being part of that new stuff as opposed to, yeah, it's a database. Yeah, we've been doing databases for a long time. Yeah, we got new stuff now and it's exciting.
I like that.
Absolutely. Yeah. Basically the same thing. Semantic search is cool on its own to play with, but it seems like just every day we're seeing more and more applications of this very simple idea of, put a bunch of vectors in a store and, and efficiently measure the distance between them, some sense of the distance between them. Finding applications all over the place. So I'm just interested to see what customers are going to do with it.
And
Yeah, I
then,
think that's the fun for the essays is how, we've got this now. So how can we, customer, how can we solve your problem? And
Exactly.
I think there's just going to be some really, I think we have only begun to tap what we can do with this.
and let's say someone wants to learn about Hazelcast platforms, like our vector search. Hendy, you are in charge
Of
of,
course, I'm gonna plug my course. There is go to training.hazelcast.com. There is a course that talks about, covers everything we've just talked about in a lot more detail. There's a link to that tutorial that Randy showed you. Instead of having a finished image search, you're going to build it. So we're going to walk you through the steps of both creating the ingestion pipeline and running the search client. So you're not just going to get more theoretical stuff, but you'll really have a practical working model of things. So yeah, go take the training. It's free. You got nothing to lose. So go sign up for it.
only learning never hurt. So that's awesome.
Absolutely.
Thank you both for chatting.
Thank you.
Thanks.